Hi, I'm Mike Roussos from the .NET Customer Success team, and I want to just briefly cover how we have added Docker support for .NET Core and Visual Studio 2017. So, one of the really cool things about .NET Core applications is that they are very small Xcopy deployable cross-platform apps, which makes them ideal for containerizing with Docker. So let's look at some of the ways we can do that. I'm out here at Docker Hub, and I'm going to search for Microsoft to find Microsoft-owned repositories. And probably the first one we should look at is Microsoft/.NET. So in here, you have a lot of different tags for different versions of .NET Core base images. And I'm going to run through briefly what these are and why they might be interesting. The simplest one is the runtime deps tag. So that's 1.0 runtime deps or 104 runtime deps. If we check out the Docker file that it's based on, what you'll see is that this is a Debian Jessie-based image. So it's a small Debian image. It's like 270, 280 megabytes. And then on runtime deps, all that's added are that we apt-get install a few packages like libcurl, libunwind, which need to be present on the machine for .NET Core apps to work. So this is basically a vanilla Debian container without much added to it. Now the reason that's interesting is because this runtime deps tag is going to represent the smallest usable .NET Core base image. And when you use this, there's no .NET Core product on the machine yet, so you would have to copy into it a self-contained .NET Core application. So to review, self-contained means that you have published the .NET Core framework runtime and host with your application. And so if you have gone through the trouble of actually maybe not including all .NET Core framework assemblies, but only the ones you need in a small application, using something like 1.0 runtime deps is going to give you the very smallest package. But it requires that you copy everything you need onto it because it comes pretty bare. Now, we also have the 1.0 runtime tag. This is going to be probably the most commonly used base image, because this is, if we take a look at this Docker file, what we get here is this is based on the runtime deps one. It also goes ahead and it installs a .NET Core framework, and it places it, in the usual location, and it exposes .NET in the bin folder. So this is that previous image, but with a shared central .NET Core framework installed. So what this gets you is a clean, small Debian machine with .NET Core present centrally, so you can just deploy your app built as a DLL or whatever and call .NET on it to execute it. You don't have to deploy a self-contained image. So this allows you to deploy a shared runtime version of your app. So this is probably going to be the most common. It's the most straightforward. We do have a couple other options. There's also the Sdk tag. So this is going to be similar to runtime in that the .NET Core is installed on the machine. But we also here install the Sdk tools. So you will have all of the build tools available. So if you want to do a .NET restore and build locally, this would allow you to push source into your Docker image, and then when you start up your image to build the source at runtime. Probably not as necessary. It's going to be a little bit bigger than just using a runtime tagged image. So probably in most cases you want 1.0 runtime, but if for some reason you need to build in your container, Sdk is the way to go. You'll also notice that we have Nano Server versions of these as well. As you might imagine, a Nano Server version of this is going to be the same thing. It's a small base image with .NET Core present, but now it's based on Windows Server 2016 Nano Server instead of being based on a Debian image. So this is going to get you a Windows container if you use one of the Nano Server ones, whereas the ones not labeled Nano Server will get you a Linux container. Now, if you use Nano Server, it's going to be bigger than the Debian ones, but it's still fairly small, and it's going to be much smaller than if you used Server Core previously or something like that, because Nano Server is optimized for just running these very small footprints like things like .NET Core. So those are sort of your options when you're picking a base image for .NET Core itself. Now we also have a couple other repositories here which are interesting. One is the Asp Net Core one, and this is interesting. It's got again Linux and Windows versions. But if you check out the either of these really, what you'll see is that it is the .NET runtime base image with just a few things on top of it. It has some pre-compiled ASP.NET Core packages to allow ASP.NET Core apps to start up a little faster, and it sets a couple of environment variables for like a default URL for the host to listen on and things like that. So this is almost the same as the .NET runtime base image, except that it has an environment variable set, and it has these pre-compiled packages for ASP.NET Core, so you get a small perf win when your ASP.NET Core app starts up. So if you're doing ASP.NET Core, this is probably the one to use, but there are some other .NET Core options here. Finally, we have Microsoft ASP Net, which represents full .NET Framework ASP.NET in a container. So now here you don't get to use Linux, you don't get to use Nano Server, so these are going to be bigger images. These are going to be, tens of gigabytes. I haven't looked at the size recently, but they're fairly large. It's still a relatively small, though, containerized Windows Server Core image with all of the components installed, IIS, all of that sort of thing that you need to run a .NET Framework ASP.NET app. So you can choose either the 4.6 or the 3.5 versions, and that's a way that you can have your full .NET Framework ASP.NET app running in a Windows container. Again, these are Server Core instead of Nano Server. So let's go ahead and take a look at how we actually take advantage of these. If I come over here into Visual Studio, I've got just a very simple app here. It doesn't do a whole lot. But you can see that I've got some Docker files in here. So in order to take advantage of Docker, each project, each piece of your application, each individual exe, needs to have a Docker file which defines how it gets packaged and run. So I've added a lot of comments here to hopefully help make sense of it, but the core Docker file itself was auto-generated by VS, and I'll show you how to do that momentarily. But what you'll see is that this Docker file is based on the ASP.NET Core image that we were talking about. It exposes a port. Then it copies everything out of a published directory into a working directory called app in the container. And then for its entry point, because this is based on the .NET runtime, and we have a centralized .NET Core image available within this image, you can just call .NET and the name of your DLL, and that will start this up. So this is a very simple Docker file. We have a similar one in our other service here. We've got two services here which we're going to start up together. You see it's basically the same file. The other thing that Visual Studio gives us now, though, is the option to create a Docker Compose project. So this is the extension is DC Proj. It's a new project type, which is specifically for Docker Compose files, which allow you to compose different Docker containers together into one application made out of multiple containers. If we look at the properties, you can see you can give it like the URL to launch when it starts up and the name of the primary service. There's not a whole lot here. But where you're going to find the real configuration is in the Docker Compose file, of course. So in Docker Compose, and again, I've added comments, but this was more or less generated by VS. I think I added some ports. I specified which ports I wanted exposed. Everything else was auto-generated, though. We list the images that we want to use. So you've got the customer's API and the customer's MVC projects. And then under the build element, we list how to create those Docker containers. So we say, okay, the Docker file is called Docker file, and it lives in this path. Oh, I also added here a link to customer's API to indicate that the MVC app depends on the API app. So Docker Compose will be aware of that when it starts these containers up. And I exposed ports, which I mentioned. So this one's going to listen on port 5000. This one will listen on port 5001, but it will be exposed outside of the containers as port 8080. So when this is running, the Docker host will have port 8080 redirect into port 5001 within this container. This container will be listening on port 5000, but that 5000 port won't be exposed outside of these Docker containers. Also notice that the name of the service here is the default for how these services can refer to each other. So this app, I set an environment variable here saying that we will refer to the customer's API application at this URL. So it's the name of the image followed by the port that's been exposed. And if I look in my customer MVC configuration file in app settings, you can see that I have a customer's API service URL defined here, which so when I'm just running this thing directly with a .NET run, it's going to expect to hit localhost 5000 because presumably I'm also running the API locally. But when we're doing this in the Docker Compose, we no longer want to listen on localhost 5000, so I override that configuration setting with an environment variable. Now here, this could be a colon, or ASP.NET Core allows you to substitute a double underscore for a colon in configuration names in case you're working someplace where the colon doesn't work. And so in a Docker Compose file, it's going to be better to use the double underscore. And so this refers to that same configuration setting, and it overrides it to be customers API 5000. So that means instead of looking at localhost, which would be local within this container, it's going to look at this other container at its port 5000 to get to that other service. So this is basically just a simple Docker Compose file, which is present in my Docker Compose project. But the real cool thing that the Docker Compose project gives us is that it also adds these Docker Compose.vs files, which it will also use when it builds your Docker Compose entity and brings it up. Now what these do, these are all auto-generated. They can be complicated, but don't be scared. They list the different services again, and now they expand. They extend them. So we're going to call the image names with a dev tag to indicate that this is a dev image and should not be deployed. And we add some environment variables, and we mount some volumes. And what this volume mounting does is it allows Visual Studio to access the Docker container through these volume mounts so that it can attach debugger. Now there is some setup that's required here on your machine when you've set up Docker for Windows or Docker however you've set it up on your machine. It'd be Docker for Windows on Windows 10. What you need to look at is if you go into settings, make sure that you've shared whatever drive your development is happening on so that these volume mounts will work properly. But this done, Visual Studio now can get into the containers through these volume mounts. It sets some environment variables, and the end result is that we're able to F5 a Docker Compose project, and Visual Studio will automatically build and launch the containers in a Linux VM running on your Windows machine, and it will then attach its debugger, which is a really cool experience. So let's go ahead and try that out. So you can see that Docker Compose is marked as the startup project. So if I just F5 from here, build starts. Let's go and open up output to watch what's happening. It's doing a Docker Compose to build the images, and then it's doing another Docker Compose up to launch these containers. And once everything starts up, we'll go out to our website, which in this case is just basically an empty site. There's nothing there. But we can see that we've successfully hit localhost 8080, something from the layout page. Welcome to the demo. This is being served out of a container being run in a Linux VM on this machine. If we were to go to home customer list, this will actually hit that other API in the other service. And you can see here I had a breakpoint set. Now this breakpoint is not even in the MVC app, which is sort of the entry point that 8080 mapped to. Customers API is the project which exposed port 5001 in the other, or port 5000 in the other container. So you can see that the debugger is actually watching both containers, so we can hit breakpoints in either of them. And then once we've hit a breakpoint, the experience of seeing locals, call stacks, using the watch window, it's all the same great Visual Studio debugging experience you're used to. But now we're debugging in a Linux-hosted Docker container just by hitting F5, which is a really slick experience that Visual Studio 2017 has added with these DC Proj projects. I'll go ahead and stop that, although I should show too, if I were to do a Docker PS, you can see that we do have these two containers running, and they'll stop shortly here. But these are the two containers that Visual Studio spun up for us, which is pretty cool. And I'll just stop them manually so they're not running for the rest of this demo. But you can see it automatically did that. Let me show you some of the other stuff that gets added here. The one other file worth looking at is Docker Compose CI build.yaml. Now this is an unusual Docker Compose file because it's not about running your application. This Docker Compose is meant to build your application. You can see the base image is ASP.NET Core build. So this is based on the .NET Core image which has the SDK installed. So this has the build tools present. But when we run it, it's not calling .NET Run. It's calling .NET Restore, and it's calling .NET Publish. So what this does is it builds your application in a Docker container. Now it mounts volumes. It mounts the volume to this source folder, which everything lives in, so that it's able to pull source from your dev machine and drop the output on your dev machine, even though the actual build is happening inside of a container. So why would you do this? There's two reasons. First of all, it's an easy way to sort of script exactly how you want your build to happen. Okay, we're going to publish into this particular output directory, which is sort of an unusual choice. Well, not unusual, but it's different than like what the default would be. We're going to build for release. And this is important because if you look at the Docker files, which Visual Studio added for us, by default, they're going to expect to copy the published output out of obj docker publish, which is not someplace it's going to go if I just type docker like .NET build. But this works because Visual Studio is building with this Docker Compose CI build YAML file, which is specifically saying this is where I want the output to go, and so everything gets dropped in the right places. The other reason, and probably more compelling reason, that you would use a solution like this Docker Compose build, since there's a lot of ways to script a build, is that this means the build process is happening in a well-known environment that can be easily replicated elsewhere. So you can have confidence that when you build on your dev machine, the build process is exactly the same as when you build in your continuous integration lab or when you build elsewhere. So it doesn't happen that, oh, maybe you had some local packages present, things were a little screwy on your dev machine, it all built for you, but as soon as you push your commits, the CI build falls over. That's not going to happen if you're building with a Docker Compose container like this, because the build is happening in a well-known environment, which will be identical to the environment that's used in your CI system if it's using something like this. So it's just a way of leveraging Docker's known state, known environment type benefits for build processes. So that's just a quick overview of the Docker files and the Docker Compose project, which get added by Visual Studio. As you just kind of wrap things up, I'll briefly show how you add those because it's trivial. If we add a new, create a new MVC project, and then I'll go ahead and open that in VS. Open project. You can see right now there's nothing Docker related here. Now we can have our own Docker files and stuff, but this process works best if it's happening clean. So if you have your own Docker file already, I recommend renaming it, letting Visual Studio create a Docker file for you, and then manually plugging back in whatever Docker configuration you had, because that's going to work best. But the way you do it is you right-click, and just in this context menu on the project, you can say add Docker support. Now we have to save the solution somewhere because we only had a project at first. Okay, save the solution. And just like that, we get a Docker file, which is just like the one we saw in the other project. Well, I suppose this is a little bit newer, so it's targeting 1.1. Great. And we get our Docker Compose. Now our Docker Compose project comes with the Docker Compose YAML, an override where you can have just like ports or environment specific stuff set, and then the debug and release Docker Compose files, which Visual Studio will use to attach its debugger. You also get the Docker Compose build YAML file. Now these aren't as documented or as commented as the one I was showing earlier, but they're basically the exact same thing. Now let's suppose we add a project to our application. We'll add a .NET Core web app, and we'll just put it next to. I mean, it doesn't really matter where I put it, but we'll put it next to this one just to keep our solution kind of nicely organized. Well, that was so we'll say web app 1, sure. So you can right-click and say Add Docker Support. The other way you can do this is that you can check this Enable Docker Support box as you're creating your project. Now if we do that, it will go ahead and give us the Docker file, and when it creates the project, it will add it to our Docker Compose files automatically. Yes, reload it. So now you can see that both projects are here in our Docker Compose. So when we do our F5, they'll both start up, and we can get that good quick loop build, debug experience inside Docker containers. So I hope that gives just kind of a quick overview of some of the Docker resources you should look at when you're using .NET Core, and some of the cool integration that's been done with Docker and Visual Studio 2017.